Hello again, guys. I wanted to go over motion graph analysis. To start out with, I have a position and time graph that I've already drawn here. Now, you just watched a video that discussed slope, and I just gave you a couple of notes about slope. But basically, one thing you need to know is we have three variables for this chapter, unit, however you want to look at it, which are displacement, velocity, and acceleration. Now, all of these are different ways that we describe motion in one dimension. Now, to get from a displacement graph to velocity, we have to look at the slope of that position graph. To go from velocity to acceleration, we also look at the slope. To go from acceleration to the velocity, we would look at the area under the graph, and to go from velocity to displacement, we also looked at the area. And the video that I linked onto the content page was very helpful looking at area and slope for position and velocity graphs. A couple things I wanted to go over a little bit in more depth is the sign of your velocity and the sign of your displacement and the sign of your acceleration. So, first of all, here I have a position and time graph. Let's say I wanted to find my velocity. Well, we know velocity is the change in position over time, or a change in time, or the slope of my position graph. So what I've done, I've picked 2 points on my graph here. This point is 2, 4. This point is 6, and it's between 8, 9. It's between 10 and 12, so it's 6, 11. So if I wanted to find my slope, I could easily say, well, my change in position would be from 4 to 11. So 11 minus 4, which equals 7. And my change in time would be 6 over 6 and 2, which is 4. So 7/4, we would have 1.75 meters per second would be my velocity. So that is to show how I use slope of a position graph, remember x is position, to find my velocity. Now, I know my velocity is constant because it's linear, and I also know that it's positive because it is a positive slope. However, with velocity, we always need to add a direction. So I want you to associate a positive slope with moving to the right. A positive slope on your position and time graph is associated with moving in a positive direction, which we have indicated to be to the right. Next week, we will talk about positive also being if you're moving up when we start talking about free fall. Now, with speed, direction doesn't matter, and positives and negatives don't matter, but with velocity, positives and negatives are very important, especially when we start solving the problems. A negative velocity would have a negative slope. So an example of an object with a negative velocity, here's my position and time graph. Here we have a negative slope. That means I have a negative velocity. Alright. I also want to talk about instantaneous velocity. So, to find the instantaneous velocity, that is the velocity at a specific time, not an average. You have to use a tangent line. So here's my graph. Now let's look at this graph first and talk about its slope so we can get a better understanding of what's going on. This graph is starting with a very steep slope, and over time the slope is getting lower and lower. So that must tell me that I'm starting with a high velocity and I'm ending with a very low velocity, or if you were to look at this section, that's almost a slope of 0, so it looks like I'm slowing down. So I know I'm slowing down, that's part of my velocity change. However, what direction am I moving? Well, I know this is a positive slope all the way throughout the graph, so I must be slowing down to the right. So I still have a positive velocity. If I would have had a negative slope, maybe something that looked like this, that would be slowing down to the left, which would indicate a negative velocity. But we're talking about instantaneous velocity. Let's say I wanted to find the velocity at this point. To do that, I have to draw a tangent line. Now, a tangent line is something that intersects my graph at just one point. So I need to find a straight edge, okay? I'm going to have to use my kids' Okay, so this is my daughter's frozen placemat. I'm going to use it as my straight edge here. Now, a tangent line doesn't necessarily intersect. So, see, if I were to draw a line right here, I would, first of all, go through that point, which is good, but I would also hit my graph right here. So I need to draw a line that's only going to hit my graph at that one point. It's not going to touch the graph anywhere else. And it's also not going to go through the graph. So I'm going to just draw a tangent line that barely touches that point and no other point on my graph. There we go. There's my tangent line. Now, if I wanted to know the speed at that point by using the tangent line, I would just pick another point that I know that's on that tangent line and then rise over run to find the slope. And that rise over run would be my instantaneous velocity, or the velocity that we're going at that instant. Okay. Now, my average velocity for this entire motion would be the slope of this straight line I've drawn here, because we're talking about our initial position and final position over some time. That's an average velocity. Okay, but here at this specific point, I'd be looking at an instantaneous velocity, the point here. Now we know here we're going pretty fast, here we're going slow. So to find an instantaneous velocity, again, you'd have to find the slope of the tangent line. And I can do that for any point. If I wanted to find the velocity at this point, I would just draw another tangent line. That's not a very good tangent line, but I would draw another tangent line and use rise over run to find the slope, and then I have its velocity. Alright, I hope that helps a little bit. Talk to y'all later.